of us online. Good morning. Those of us online. Good morning. Those of us online. Can you hear me? Hello.
We can hear you.
Okay, good. Welcome to this segment for our ability discussion. And those of us physically, and so you can see me, you're equally well. We have done the main work. We started the real work last time. We are continuing. If you can recollect, I've defined this for you. Have I? I defined it. I said all those random experiments, there are probabilities. Is what we call I was able to predict that. But there are some other ones I want to just add. Which see should try and this. Yeah. Okay. We're still yeah, so we're looking at okay. So okay, those of us online are ready now. Number one, the lonely, the oh, oh, the lonely, yes, the lonely. Also another random experiment out there. The lonely, another random experiment. So right, random experiment. Random experiment is called a Belloni. What is also now we did that just okay. Random experiment is called a Belloni when it has random experiment is called Belloni when it has only two possible outcomes. Oh wow. When it has only two possible outcomes. Oh, all right. So I write this, I'm writing this. Then look, say, what you end what say women. Yeah, you know what I mean? I'm using this. Still a continuation of practice that was started. Remember, it was random variable. I mean, a double N. Alone. So I start. I say random experiment. You are aware that that random experiment, the result of that random experiment is called random, which is X. And those X gives up probabilities. And that is probability to remove. Random variable. Sorry, a random experiment is called a random experiment is called a Belloni when it has only two possible outcomes. Is there another cause and reason? And we have research. The other one is quantitative analysis, and that should be in the one second. This one is statistics, actually. We also call it research methodology 2. That one was 1. This 2. And this one is all statistics. That one is a mixture of mathematics and statistics. But this one is all statistics. Okay? So, we move. I said when it works, when it has two possible outcomes. Two possible what? Outcomes. Two possible outcomes denoted by Simon, denoted by B for success. For success. Denoted by B for success and Q for failure. B success and Q for failure. That will us. You know that probability of success A and I is B. Probability of failure is what? Q. And you are aware of what you have written for that and the probability of success plus probability of what? Failure is equal to what? 1. You know that. No. What was here is 1 minus B is what? I take two. So that's what there's a and one thing about statistics, I make it hours exchange and self this one. So okay. Full stop. Okay. Full stop. Hence, a random variable. Hence, a random variable x. We all know that. Random variable x. Hence, a random variable x with two possible outcomes. Random variable x with two possible outcomes. With two possible outcomes. P and Q. We all know P and Q is alone. Is and Q is a balloon. Let's do it this way. Let's find this. An expression. An expression x. An expression x. This symbol means test to Wesley. No. Have you seen that? Those of us online, I hope you have put it. Like this. See what happens. S tends to P. Another P is success, P is success. And the opposite to what? Which you know is Q. This symbol is like a small dash. So dash. Anyone? Can be read as X is a random variable. Random variable. Reads as X is a random variable. This symbol is that X is a random variable. which tends, T-E-N here, which tends to behave, as a Belloni distribution, which tends to behave as a Belloni distribution with parameter, P, parameter P, where P is probability of success. Where P is probability of success. Okay? But see that? I just start like this. There into capital of P. That means that X is the random number, which tends to give us what? Belloni, right here, with the parameter P. And P is probability of success. With this small grammar, our expected value of X is what? P. That means when it comes to Belloni distribution, which is part of Belloni distribution, they mean by expected value of this X, which is random variable, for Belloni definition of Belloni distribution, answer is what? We'll talk about. And when variance, which we talked about, variance is what? Q. I hope you are following the formula. Sir? It's not like when we are solving that, we look for expected value of this. We are multiplying. And we got about yes, 3 times. Because you know, if you want to see further, standard what? Relation, experiment. Let me go say right this. The question says, I want to but you know that standard what? Standard, which I believe you have experiment of what? I mean, I know that what's this one? Oh, we have not understand. Don't want to write. Don't want to let you back what we have done before. I mean, but they can tell the question and see the question. We will just give you this. That B will be a value. So I'm going to see. I'll tell you to find out this. But the one that is always common facts. For in case they expect to tell them, they should not do that. Yeah. So in case they do, there's nothing wrong. Remember, Belloni is the primary distribution, which has a correct P, and the mean is expected variance is P. Variance is P times Q, validation, coefficient of variance are also. Let's take example. Question 1 for this. Let's say if X is a random variable that behaves like P, and let's say 0.3. Are you there? The question say then find a expected value of X B variance of X C standard what? Deviation NG coefficient of variance. We all know how to do it. Just have to be all right. Remember, such probability of what? Probability probability of success is 0.3, I think. Probability of success is 0.3. Probability of failure This is like 24 minus 3 are 1 minus 3, 11.7. Those of us online and get any question, that's the best thing. Who's not clear? Here's our question. Here's the parameter which you know is which is success. So everyone that when you have success, must find what? Failure. And when you have done that, you able to find expected value. X, variance, X. As far as Peloni is concerned, this is the information that we're going to use for Peloni distribution. Is it clear? Those of us online, any queries? Ask question on start. There's nothing in it that we cannot understand. Okay. Are you there? Not to waste our time. Okay, let's just go on. So, if expected value of x equals b and b so by b and b, is it difficult? Very b and variance of x equals b times what? And this 4.3 times 4.7 is not difficult. The other thing is that you don't know the that's one serious point of the government. Maybe see now, we'll talk about standard deviation, which square root of variance, automatically has square root of square root, which I believe someone 4.8 like that. Then he first coefficient of the variance. That one is just time when you are in the switch, like standard and this one is 0.458 all over 0.3. And the value comes. Those of us online, are you following? 1.52. And that's God. Let's come to the past chapter. Under the past chapter, please. Those of us online, any questions? First one, remember the formula? You have the result. Not that. How true? Those of us online, any question? That's all about Anthony. We're moving on to graduate. There's nothing to ask. Like I saw in that pastor say, but they don't mean what is the mean. They don't mean is what. That's similar. Another just are you there? Next, binomial. Binomial. This one has got eight. Nothing there again. Binomial. I know it's only one. I'll let you remember. Let's finish this. So only having 1, 2, 3, 4. So only against this. Now, oh, good. Probability function. There's also one this binomial. Also, I was that's so I'm just there's binomial oh that's fine. Multiplication. So, but this one is part of this one. Let's go. Consider a balloon. Consider a balloon trial. Consider a balloon trial. Repeated. Consider a balloon trial. Repeated independently for n times. Repeated independently for n times. Alphabet n dash times. Repeated independently small n for n times. Full stop. x as we know capital X. Let x be the number of successes. Let x be the number of successes observed among the n trials. Observe among the n trials. Observe among the n trials. Full stop. This methodology has an XX which is like anytime I see BI, it means I go another thing. Another PI short. Times PI is binary. Right. Okay. And put it back in the next one. That's all B. The parameter says n and what? B. I know that n is the number of trials. Number of trials, that trial, split over and over. Split over and over. That is the trials. Okay. Now, you know P already, success. I know the other one what? Failure. Q. So that one is strength. But the two parameters you look at n. When it was binomial, only P that is here. But now that is binomials, n and P that is parameter. Is that okay? So n, you know what is n, and the problem becomes so. Don't forget, formula for this expected cost, which is mean. Our mean will not be like the other one. So remember that one, the mean was P and V. So this one will have what? So the variance was E. iPhone. I said n what? So okay, don't forget to the formula so immediately you know which one is which. Because when they ask you, I know me, when it was expected value of cost, because by looking at n was better, and because variance join n b q, that would be better. If then you get this two, you can get that. You can get so we make this one, this one. One. Let's x if I look at 6 4.4 like this 6 4.4 then find Roman expected value of x expected variance x standard deviation which number 4 coefficient variance. What this becomes so easy. Already is on the board. Probability of success. So that E is 0.4. Yes. Probability of success. You know that 1 plus minus A, 1 minus 0.4, result is 0.46. And you know that n here is got 6. The goal is to go how to define all of the same from the board. Outside the big problem. So to solve the question of one, expected value of x, the expected value of x is n, and n is 6 times 4.4. Good. Result is 2.5. 2.5. Good. 2.5. The Roman 2 variance of x is n and n. N is 6 into 0.4 into 4.46. I believe multiplication Check on my so as a problem. Those of us some like I hope everything. Anybody there? Are they there?
We are here, sir.
Okay. Roman people 3, standard deviation is okay, the square root of the parent, which is the square root of 1.4 is equal to 1.1. Roman 4, division of parents, standard deviation all over 7.5. Here is 1.2, 2.5. Is that correct? Are you still with us? 1.5. Okay, 0.5. Good. So we have seen how this one looks like. I have to find the learning and go here so that we should get more results. We don't have the starting. We don't have. Say elaboration. The law is object. But what I'm going to talk about, let's say it. I is allowed. Because that's so. Let's have it. This is elaboration. Except if you talk to this, whether they are you can get just as it is. No. God is saying, that one is 4 secondary school. But starting before starts how high was why everything you lecture. Because I'll tell you what, when I exam, I'll just take my own because I've solved my own. I call it. I'll just tell you that. So it's then properly look at what I follow it, whether it's my that. Even they are not actually game because after some we have the F that we have the F for now. Then compare it, but you must already see that. But there's something like we don't know it. And you can say, that is that. We go carry on. And you can F from when random. That one is random. Oh yeah. But not talking about so there's one reason why the song based on this mass or mass. And if you buy some test, for instance, test I have if it's a statistical, if you check some of them, have that thing. But you can't find that thing now and then. So it was just like some say we don't want to because this one I did, I just did. But the next question I'm going to this I know we need them and boys, the boys we need them. For some we need them and which one? Another wasn't the table. But the table is small thing. But the real one for another is small. But the table is the smallest thing. But in that table, you can't see the observation, it's also part of hypothesis. Before we like discuss more. So the progress. No regret. Uh, no. And if anybody was there, up, say the name of God. So, no. It's for her. But there's no guys. There's no guys. There's no guys. And there's no problem. But what I'm saying, when you talk nice, that's CHI. Where you talk, was it part of the system of the jogging? It's not part of the work. No, material. I've seen so many material. You have so many people. But the person was having to talk. You have not another. He wants another table. It's not for now. And we are saying that currently, I will be taught nice. But another you have taught. We're not taught another. Okay, everything else has not such that approach, that perspective, there is something. But when the day that's us, because like some of one, they include statistics and so include science, which was not there. So they just included, but it's still part of the main perspective. But you know, say some people that they just choose what they will cover. So it doesn't mean that every side there must be what's the problem? I learned how to do that. Those of us online, I draw question number 2. I'm still using this question 2 from the parent distribution. That is the origin of it. Parent distribution, evaluate the following probability. Evaluate from that is from this guy. From this. I is a parent from this. They will give it or from this one.
Please, sir, they should please help us snap the board.
Okay, you are not seeing the board again. But okay, write this one and fit from the parent distribution, from the parent distribution, evaluate the following probabilities. Evaluate the following probabilities. Full stop. Everything that is let x tends to pi into 6.4. That's what I wrote about it. What I wrote before? Yes. Yeah, just trying to get. Find question A. Find A E into x less than or equal You remember this term? The probability. You know this random variable. The probability of this equal to 3. But that one, but this one is x equal to 3. You know what we did this time? So that's still x probability x greater than or equal to 3. So I'll show you how to do less than or equal to 3, how to do equal to, how to, that means anything they give exam, whether it's 4 they put there, which means I'm trying to put less than equal to greater than. I know that inequality is like that. Let's see. So this one I will just in this statistical, I want to write it down. So, and find out that or not, so that you understand it. Are you ready? Let me go ahead. Can you see it now? Or snap it? I hope we are copying. Those of us online, those of us physically, I can see no problem. And those online that I don't see, please respond to. Have you finished now? Yeah. Because I have to write it down. As I can't carry it. Because it was this. Oh, let me see. Now, and the first question says, if probability of x less than 3 is equal to the value of 3. The value of 3, under the value of 3 under n equal to 6 in sorry that you can't that place I wrote 2.4. This last one. Please write up. Hold on. You know I wrote left x. I wrote like this. X6 I wrote 2.4 here. I'm changing to 3. Wait. Because I've checked this what I saw. So if I put 4.9, what you see, I begin to worry yourself. That one I saw before was 2.3. I've done it with variance. And with table now, what I'm using is 0.3, not 0.4. So that when you get to check the table, so our table now is value of what? 3. Value of what? 3. That means when you get that 3, it has 1, 2, 3. So you look at 3, I for the value of 3. Under n, n is what? 6. Probability is 4.3. You have 6. That value is your what? Answer. Because when it is less than or equal to what? 3. Now going to the value of what? Under n, 6 times again. Probability is 0.13. Is that okay? And whatever you get is the answer. What you're going to get you there from my table is 4.930. And this is the final answer from the table, not me. You can't solve this system. The other one we saw, that was manually. Expected value of that was manual. But anytime you study exam, probability of x greater than equal to 3, probability of x equal to 3 greater than 3, all this thing. You can't solve with that. And like I said, statistical table. And that's a statistical before that by distribution quadrant, but there's chi-square quadrant, there's a normal distribution, there is Gaussian distribution. We go under the check it. But for this one now, so 6 and the yield there is 4.9. That's it. For B, it's just give not be that. That's why I have to go out so that I don't get exception. Probability of x equivalent to what? Is 3. So because this 3 equals to 3, I look at it between 3 and 4. Between 3 and 2. You look for value. Value of 3 minus value of what? Value of 3 and 2. What's the value of 3? Just one. And we look for that of 3 and 2, which happens to 0.7. The difference will give us the answer by looking for 0.186. Are you with me? Good. You have to check this out. It's working now. Not working. Just working. But you know when it's equal to 3, talk about 3. When it's less than equal, under 3. That is so this one is 2. We're talking about 2. Under what? And probability of give us.
And excuse me, sir. Excuse me, please.
Yes.
Good morning, sir. Please, where are you getting all those figures? Like 0.930. Where did you get the figure?
Do you have statistical table?
Oh, okay. I don't have the table.
Have you bought?
I don't have the stats table.
You just have to go shop and look for statistical table and check for this question. Value of 3 under n 6 probability 0.3. This value will show as you can use
Okay.
But this one is statistical table under the binomial distribution. Check it out and confirm so that by next class you'll be able to let me know whether I want to solve this thing is it. Is that okay? For this other one, we are looking at value of 3 under 6 probability of 4.3, which is this. Value of 2 number of 6 probability of 4.3 is this. The difference is because probability of the random variable where x is equal to 3. That's and the same thing as value of 2, value of 3, under what? 6, probability of 0.6. Question says that probability of x. Yes, when is it possible? We know the difference between 3 and 2. Forget it. So must be that we look at 1. That is it. So in that case, finally, this one is greater. Probability of x greater than or equal to what? Is equivalent to 1 minus probability of x less than or equal to. See this one, please stay. Are you sure you're well? Now, if you look at this one, this greater than or equal to. That is nothing. So it's more. Can be moved. cancel board. So it's going to be 1 minus quantity of x that I know that this one will be 2 under what? N equal to 6, B 0.46. But we are here, which I go to get on the board. I have under 2 and 0.711 and the result is 0.256. All these ones are not factor. Is the table that said value, and I just put the table there the way the elders say I should. It's not one my the elders. Thank you very much. Yes.
I don't understand. What table?
This is Excel and the access. Outro. Okay, let's remember the table and then see where the values are not statistical table. Just walk into it, so then you need that to open it and look for binomial distribution choice. That's binomial distribution, Poisson distribution, normal. No, it's the difference. Most of the classes only does Poisson normal. So, and there's also another thing that table line. Yes. So I don't know. There's tendency, but it's based on there's tendency like we are provided with what they can just throw it and give. The friends, those that invest and take them as student if you buy and you can get to start with that. No. That on the exchange school application. I think if it's there, if you can generate are you sure? This one. For subjects. Okay, that means that they should give you something guys. Because stable will use all this time. Be something stable. For the other ones, and the idea is the same. This idea is the same. For us, say 1 man greater than same. How much same man? The rest is the power. Let's do it normal one that has expected, which is that one is easy. Alright. And they won't be lucky because if they cannot provide, they may as well sell. So just put one like expected by this kind of thing. So, but whichever one, they should get it if they want to answer the question. Okay, let's go to Poisson distribution. Already? Those of us online, are you copying? Those of us pressing phone, are you copying? Let's go. Just one. So this one is after this one more. I will go to another. That one we don't need to take one till end. At least we must have finished. Or talk about as if this happens. Well, Poisson distribution. Already? And I move something. Here's the third one. Distribution. Poisson distribution is obtained. Poisson distribution is obtained as a limiting form. As a limiting form, Poisson distribution is obtained as a limiting form of binomial distribution. Limiting form. Yes, it means the third distribution. We have done one.
A limiting what, sir? A limiting what?
Limiting form as a limitation. Limiting form of binomial distribution plus limiting form of a binomial distribution as n, look at that arrow, as n becomes larger, hence, you know that in binomial construct, as n tends away toward larger, comma, b tends to the zero, smaller way, okay? You know, I know it has n tracks. This is at the end of the computer. Why the probability of what success reward, which is smaller, that's what makes it poison. Push up. No, it's n tends to zero, not less than that. It's moving to zero, which is n. Push up. Hence, comma, hence, comma, hence, comma, the product of n, the product of n and p, the product of n and p gives the only parameter, gives. Hence, the product of n and p gives the only parameter of Poisson. Poisson. You remember that symbol? Did you remember this symbol? It's like
Lambda.
So, by the time you multiply n times n, go to a particular value, and that value will got double. And because it's now Poisson history. Is that okay? What was saying is x tends to PO. PO is Poisson. For you to understand. Poisson. PO, Poisson. So this is the symbol. Talk about Poisson. So which means the simple language where n times God be.
I can't hear anything. No.
I think it's from their end. Oh. So let's just hold on.
Okay.
Can you hear me now? Yes. Hello, can you hear me?
Yes, we can hear you, sir.
Mm-hmm. Were you able to see the Poisson distribution on the board? Did you got that? Did you get that? Okay. So let's take a small question there and see what we can do. Get that table and see what you can do. The one involving table. Let's just run this one like that. And a question like this says if x is a random variable, for those of us who are just joining, which is like a Poisson, our lambda, let's assume our lambda is 0.6 in this case, then find a expected value of x, the variance of x, the standard deviation, then g coefficient of variance. Solving this small thing, which is not a problem, I believe. We have a expected value of x is lambda b, and that is 0.1. B variance is also lambda, which is also 0.16. Very simple. If there's have questions, I don't think we have any problem. The square root of variance, which is equal to the square root of 0.6. Result, what do you have? Anybody? You said 0.7746. Okay? The D coefficient of variance, which is standard deviation all over expected value of x. Standard deviation is 0.7746 all over 0.6. Have it? 1.2 like this, have it? You are getting the answer. That means you are doing well. Doing well. Doing well. Any questions? We'll take one more, which is the normal distribution. The other one, like I said, is statistical table, similar to what we did at the beginning. So let's not bother ourselves.
Excuse me, sir.
When you get a yes,
Hello, sir. Please, I
I
have a
can hear you.
question.
Please
Sir,
ask.
please, how can we apply this to our everyday life?
I told you this course you are doing is called research methodology. That means, I mean, or something like that. Quantitative research is there. Research is there. So, somebody is trying to understand things. So, this is research, whichever one, quantitative research methodology, whichever one. But we will use this for research. And in your research work, you will come out with a result. And that result will help to actually shed light on what particular challenges over the years or currently. How easy to solve the problem. Just like in the higher institution, the lecturers are employed for three purposes. One, to lecture, two, for research, and the third one, community service. It is some of their research that become solution grant to whatsoever that have happened. E.g. is Adam Smith. It is something about the division of labor. And till tomorrow morning, that is the theorem that is working. So this is for research purposes. I will use it to analyze. Is it clear? Can you hear me?
I can hear you, sir. It's fine, sir.
And so that is the reason. It's not that we are just writing it, it's for research. So put this one down. Let's take one more. Normal distribution. Let us see how the parameter works so that we can answer questions that relate to that. Are we there? Let's quickly take the normal. That one too like that. So that can I play? Those of us online, can I play the ball? Okay. Let's quickly take this one so that we can move on to another. There is a normal distribution. Normal distribution. Normal distribution. It's okay, it's okay. The Lord understands. The Lord knows why we are here. Let's quickly take this normal distribution. Remember, binomial goes with DR, right? Binomial goes with DR. Poisson goes P. small o down, okay? And why normal goes with capital N. So let's see. Normal distribution. A normal distribution is the most widely used distribution. Normal distribution is the most widely used distribution in applied statistics. Normal distribution is the most widely used in applied statistics. Full stop. As a result of this fact, I said normal distribution is the most widely used distribution in applied statistics. As a result of this fact, there are many procedures. In applied statistics where normality is assumed to hold. Where normality is assumed to hold. I take it again. As a result of this fact, there are many procedures in applied statistics where normality is assumed to hold. Full stop. This distribution is usually expressed as x. This distribution is usually expressed as this capital N, this mu, this sigma square. This one is me. This is better. Good. The square root of this is sigma. Original sigma square. Better. So it's not new to you people, have it? This mu, which is me, population mean. This population variance. That's what it means. Where mu is the mean, and the second one is the variance. I hope we agree. That is settled. Is that okay? I'll not leave it at that. They know. But let me have that very small grammar here. It's okay. We know that this mean having this better. Let's move to the next agenda. Yeah. No, this one is a normal distribution. This one is a mean. This is variant. We know those stories are following. Let's not waste time. Let's see whether we can start this or not. Even if we don't go far, but at least we must have started. I don't want only this one to be the matter. For ability distribution, we have done some part of it. Am I correct? So let's not cheat this one. No be like so no that. I want to talk about ANOVA. ANOVA simply means analysis of variance. ANOVA. ANOVA. It simply means analysis of variance. And we make use of that if the Z statistic and the T statistics are not going to solve the matter. Then, because it's large, we'll now bring in another. Another will help us to solve the wahala. When those two have failed, which means because Z, which is normal, and the T, Z is normal. T is just T calculated, T statistic. We call that T statistic. So that was a T calculated to run it. So when those two cannot solve the problem, we'll bring the elder brother, which is another. Another will help us do the work, which is analysis of what there is. And there are ways of handling that. I will have different types of what another. We have one way, another. We have two, we have three, and so on. I could remember in those days in 2003, 2004, when I was doing my first MSc in mathematical studies. I was calculating so much another because from my department, University of Lagos. So we calculated so much that we were tired. Every small time, the prof would say, calculate. And I said, okay. And every small minute, calculate. One way or another, two way or another. And the thing will cover so many pages. But thank God, what you are doing is just one way and another. Just one way. It's not two. Only one way. And let's see how it works. Let's just give you small notes, at least to help you understand before we take a question and start calculating the total, the mean, the y square, the correction factor, and so many other grammar they decided to give us. Is that okay? Okay, let's give you this small note. Okay? Okay, let's take it like this. In the process of texting, the equality of two populations, in the process of texting, okay, I need to write. Those of us online, we have left probability distribution. We are now moving on to another. So that and that number simply means analysis of what? Variance. Now here we did now. Is it clear now? Good. Another. I said, what did I say? In the process of testing, the equality of two population means equality of two population means using Z or T text. Using Z or what? T text. Using Z or T text. Comma. If there are more than two population means to compare. If there are two population means to compare. In other words, one with Z, they were having just two population means to compare. But whereby the thing now goes into 3, 4, 5, Z and T cannot do that, except what? Another. So if there are more than two population means to compare the Z or T text becomes inappropriate. I hope you are getting where we are going. Because when you are comparing now a column, 2 columns, 1 column to find the population mean, second column, 1 find the population mean. We want to know that the population mean of the 2 are equal. or not equal, which is alternative word hypothesis. Now we tested that. If we now have up to 3, 4, 5, 6, Z or T cannot do. Rather, analysis of variance can run that. Is that okay? So it becomes inappropriate. Full stop. In place of a Z or T text, in place of a Z or T text. Hello?
Sorry, sir, excuse me. Can you take back the if there are two population?
Okay, there are two. Okay. No. I said if there are more than 2 population means to compare. Are you there?
Yes, sir.
Okay, if there are more than 2 population means to compare, comma, the Z or T text, the Z as in Z on the board, Z like this, and then T text. Z or T text becomes inappropriate. Full stop. Is it clear?
Yes, sir.
Good. In place of a Z or T text, we construct a new text procedure. We construct a new text procedure. Text TES, not as in texting message. TES. We're still on text. This one. We construct a new text procedure, comma, namely analysis of variance or ANOVA for short. Analysis of variance or ANOVA for short. That is to tell that ANOVA is here to solve a problem that Z or T text cannot solve. Because ANOVA can accommodate 4, 5, 6, 7, 8 columns. But unlike Z or T, only accommodate 2 columns. 2 means maybe a particular column now could be on want to text 2 types of drugs. iPhone. Drug A, drug what? B. Z or T can do that. Or have drug A, drug B, drug C, drug D, drug E. Z or T cannot do that. But analysis of variance can do even much more. Is that okay? Full stop. Paragraph. Already they know that. Okay. Let's still the literary meaning, let's still write in case. The literary meaning of ANOVA is to analyze the literary meaning of ANOVA is to analyze the total variance or variation. The total variance or variation in the data or variance. Variance there is different or something like that. Or variation in the data. Full stop. One way another means that there is only one factor. One way another means that there is only one factor apart from the ever present random factor. There is only one factor apart from the ever present random factor which causes the data to vary. Variation, variance, to vary. Full stop. In the drug manufacturing In the drug manufacturing company, comma, the factor, which was that is the question I'm going to do. Drug manufacturing example, which I'm going to look at later. The factor which causes variation in the data are a treatment of drugs, treatment of drugs, and b random factor, full stop. So the main idea, continue. So the main idea in analysis of variance, is to divide the total variation, into components, to divide into variations or into components, total variation into the components that generate the variation. Components that generate the variation. Full stop. In a one way another, we partition the variance. In a one way another, we partition the variance into two components. Into what? Two components. Namely, alphabet A. Namely, a variation due to treatment effects. B. Variation due to random error. Are you there?
Sorry, what did you call B?
A is variation due to treatment effect. B, variation due to random error. That's what we call error sum of square. So that's the random error. An addition of those two will give us total sum of what square. We'll get there. Paragraph. The essence of a text of significance. The essence of a text of significance in a novel. The essence, that's what we call level of significance in a hypothesis test. The essence of a text of significance in a novel is to compare A to B. That is variation due to what? Treatment effect. B is due to what? Random effect. Is to compare the A and what? B. A is variation due to treatment effect. B is variation due to random error, which we call error sums of square. We'll get to see A to B. To see if there is a significant effect, of treatment or no, I'm not reading for them. I said the essence of a text of significance in a novel is to compare A to what? B. To see if there is a significant a significant effect of treatment, or if the variance is mostly due to random error. Treatment, effect of treatment, or if the variance is mostly due to random error. Full stop. The text procedure, as you're hearing text procedure, that means we're written idea to be touching hypothesis test somehow. But anyhow, we still look at that. Let's just tell you small thing about it. The text procedure is now given below. The text procedure is now given below. Suppose there are K treatments. Suppose there are K treatments. K treatment groups. What it means is that drug A, drug B, drug C, that's the treatments. Treatment one.
I will see the promotion exam.
I don't know.
So I say the man, I know it's good to prepare. Say you have something that
Yes.
if you don't have, I should move this one.
Oh, it's too much. Okay. Like I was saying,
Please mute.
supposing there are K treatments.
Yeah,
A K treatment
maybe it's from here.
Supposing there are K treatment groups.
Some people are saying the chairman doesn't want to.
I mean, K as in king, like K.
Once you just
Baba Ghana,
give us
please
escalating. So I don't know if it's true. So I think I
There
give
are
it for
Someone is
that's the challenge. So it's good for one to prepare. If
Baba Ghana,
you give
you're
us
just
five,
are you just
but if
listening?
it's going
Ghana, please
to
mute.
you
Baba
do
Ghana,
this man did. They will say they will follow KPI.
Suppose
And
there are K
you know
treatment groups.
we now.
What I'm
Okay,
saying
they are waiting to give me 90. My
Baba
country
Ghana,
now.
mute yourself
This
now.
one I should give me it. I said
there is
admin, can you
okay.
Baba Ghana, admin, please mute Baba
Abuja
Ghana.
they give their people
Ah.
90. When they do this low, at the end when they say they need something, we
Baba Ghana.
that's what she can. So those are the things.
Mute yourself now, that guy. So supposing there are continue. Supposing there are K treatment groups.
Anna, well done. No,
A,
today.
drug B,
Well done.
What is that?
Yeah, thank you.
drug B.
Yeah.
Those are the treatments. K treatment. K there is 3. That means if it's 3 treatments. 1, 2, 3. No, K is 3. The treatments are 3. But if we want to find degree of freedom, subtract 1. It will give us 2. Or we'll come to that one. Let's see, because this one you don't put 2. I know you don't come more 1. So that is K minus 1. Leave that one. We'll get there.
No, please, Baba Ghana, can you please mute yourself, please?
So suppose there are K treatment groups. And for
Baba Ghana, please, can you mute yourself, please?
for simplicity, we assume there are n observations. We assume there are n, alphabet n observations. There are n observations. We assume there are n observations for each treatment groups. This is what I'm saying. I have 1, 2, 4, 5. I have 2, 6, 7, 8. I have 1, 4, 3, 8. I follow. This is first treatment. Second, third. The number of observations down here. This one go. This one go. How many treatments? Good. They are mixing up. So suppose there are K treatments down as well. For simplicity. No, don't worry. We'll get a person that will look like. No. Supposing there are K treatment groups, and for simplicity, we assume there are n observations for each treatment group. Each treatment was group. Full stop. For each treatment group, n observation. Full stop. Abi? Yes. Full stop. I don't want to bore you with so many statistical language. Let's just go straight to the point I'll take a question. We'll be analyzing it one after the other. But let me just put some table and show you one or two things to at least so that when we see the question, we'll not follow that format. It will be as if it's the format. This one way, another table. There is a table. I have something like this. I have the source, which some people call source of variation. Source of what? I don't like source. Okay, make a definition. Source of variation. I have this. Then the next column I will have is degree of freedom, which I believe they have not forgotten. That's DFIB. We'll have this. Another column for us to have is the sum of squares. Sum of squares. Sum of squares. SS, I mean. SS. We'll have like that. We'll have another column. Mean sum of squares. Mean sum of squares. That is MSS. Mean sum of squares. There is a 1, 2, 3, 4, then 5. Some people will say it's F calculated. Some will say it's F ratio. Whichever grammar anybody likes, they can use. Remember we talked about treatment, Abi? Treatment. Treatment, that is the treatment due to effect, or what we call treatment sum of squares. And that treatment, degree of freedom, is K minus 1. So now we're talking about K. If this is 1, 2, 3, K is 3 here, Abi? So 3 minus 1 here will be 2. K is 3, 1, 2, 3. The columns, the groups, and the K. K1, K2, K3. Observations 94. And that is N, Abi? Good. We'll come there. And there is a small N and there is big one. Something like that. But let's just concentrate on this one. This place is a TSS. That is a treatment sum of square. Treatment sum of square. We have a formula. We get there. We'll show you. Another one is for us to get this place is TRSS divided by K minus. Look, if I've gotten this over this will give me this. I hope you are there. If I've gotten this, there's the formula to get it. So if I've gotten this over this will give me this. Well, let's just draw the table so that they can see it like this. This one don't go. Here is the treatment we're looking for. This is the source. To get the degree of freedom is K minus 1. That K is the number of groups that we have. We have 10 groups to be 9. We have 5 groups to be like that. Is that okay? Fine. You're welcome. Now, another one is, this is that error we are talking about, Abi. Variation due to error or random factor. Okay. That error here is going to give us, some will say K into N minus 1. Some may like it like that. Whichever one, still okay. But this one is better. You understand this one better. Then this one is error sum of squares. If I have gotten the total, this one is TRSS. There is TSS, total sum of squares. This one is treatment, there's R here, treatment sum of squares. And there is total sum of squares. So if I get total sum of squares, I take away this one for total sum of squares, I'll get what? Sum of squares. No, this treatment sum of squares. TSS is total sum of squares. Addition of this to this error sum of squares. Yes. And you know what I just told now, that error sum of squares divided by k into n minus 1 will give us this place. This divided by this. Don't forget, this side no dey change. Merely you have gotten this. How to get it? I don't think anybody is getting point with this. K minus 1. If the treatment group is 20, it will be 20 minus 1. That one is very clear. For error's sake, what you are not seeing. That's our opportunity. There are some errors we are not seeing. Minus 1. We'll take it like that. Now, okay, this one now, this is where the total is. The total sum of squares. So I'm writing this so that we are getting the formula, even if I did not finish solving everything now, because since I see your teacher, the guy is coming around. I think you have something. It doesn't matter. We still, what can we do? What matters is that we have started and we are trying our best and we cannot kill ourselves. So get this place. Yes, we can. We have to take it in. You want to kill yourself? You have to take it easy. Finish them. When the guy don't be around, I can delay. Are you seeing it? What again? This is very simple. Immediately I've got this and this. Math I don't solve. This divide this is this place, are they? This divide this place. This over this is this place. Everything is in order. No stress. No stress. So nothing there. This is total, abi? That total means simple addition. And if I add these two together, I believe I'm going to have k n minus 1. You know that n is the observation, abi? Observation is 1, 2, 3, 4. 4 times 3, 12. That means that this n is 12 times 3. In this case, the treatment is 3 minus 1. That place don't come. And you know that the value here and the value here, add these two values together, you get. You don't start. We're trying to show you formula now. Don't be talking about that. We are showing you how things today. The formula is complete now. Everything don't do okay. It's not left for us to take a question. But I'm not trying to do like another. What's important like a test? What's important? How do you construct a one-way another table? But the table it is. Even if I don't solve anything, you go understand it. Two-way no concern. Still your name. No, not. Are you statistics student? It's for statisticians, not mathematicians. Statisticians are different from mathematicians. Statisticians do more work than mathematicians. Because statistics is the application of mathematics. If you don't know math, you can't understand. Are you following? Because statisticians calculation plenty, you can't so many things. Formulas, statistics get plenty. And both. Because what I studied in math department in Boston is MSc Mathematical Statistics. That's what I did in 2004. That's a long time. Now, these are formula.
Why is there no formula for this?
Which treatment? There is formula now. I'll give you now. So this one. If this divided by this, and I give us no nothing there. And this time I get that color. This F can I get this color. Somebody will decide to carry this and put here. Or put here. But anyway, like some people may not even draw line. They will just say that is the color for that matter. Just what is different now is how to get it. How to get it. Every other thing is in order. Yes, so let's see whether we take a question. Even if we take it, we'll know what to do. I'll tell you. This guy, The production, yeah. Production. Let's just take the question whether I can manage about is addition. This plus this. This plus this. This minus this. This plus this, you get it. This minus this, you get it. This minus this, you get it. Yes. This K minus this one, you get it. But you don't need to do that subtraction yourself. It's just a formula, right? Which when you see number, if this one happens to be 2, and the total is 15, the difference will be what? 13. But let's see whether all this thing they talk, whether it's a 3 better. Let's just take a small question. Are you ready? Question 1. Just, I'm not being hypothesis here. I don't want to say HO is equal to mu 1 equal to mu 2 equal to mu 3 because there are 3 treatments here. We want to compare what their means. Then H1 will be equal to mu, not equal to mu 2, not equal to mu 3. And we start solving. But we just want to calculate. If we get to hypothesis testing, we'll just show you what it is. But for now, we want to get the table. Because by seeing this, we're already doing hypothesis testing. But in a simple language, this is what we're trying to do. Let's write it, but we don't know. HO is equal to mu 1 is equal to, that's after my question, mu 2, and then mu 3. Then H1, which alternative is equal to, is not equal to mu 1, is not equal to mu 2, is not equal to mu 3. And by this, we're doing what? Hypothesis what? Testing. Is that okay? But what will happen is just to fill in this table. Let's take question. Question. Here's our question. What shall let's? Nothing there. That's it. Have you written it? So let's take a question. Those of us online, I hope they are copied. Question 1 for this topic. It is best, BES, it is best to construct an example based on the drug manufacturing experiment. It is best, BEST, to construct an example based on the BASED, based on the drug manufacturing experiment we have described earlier. Now we're talking about that and described earlier. Full stop. The following measures of relief from malaria. The following measures of relief, that's good, relief from malaria are obtained from a sample of 18 malaria patients. Full stop. The treatment being assigned. Randomly. The treatment being assigned randomly to 18 patients, such that 6 patients, oh gosh. The treatment being assigned randomly to the 18 patients such that 6 patients are peace, 6 patients are peace got a, a got a piece, yes. Got, oh, that's it. 6 patients are peace got placebo.
Sorry, is it active? I don't.
Oh, drug. Okay, let's do this. 6 patients got, let's do this. So, thank you. 6 patients got a piece of placebo. That's the name of the drug. Place, B-O. Placebo, comma, standard drug, and the new drug. Placebo, comma, standard drug, and the new drug. There are 2 drugs there, 2 treatments administered on what? Patient. But 6 got the first time, another 6 got the second time, another 6 got the third treatment. Is that okay? In all, the whole patient got 18, but those that got different type of treatment are 6 in a group. Analyze these data so as to recommend whether or not the company should introduce the new drug, full stop. All of them are new drugs, you understand? But I just want to make one to be somehow. Finally, let's see the table. We'll continue from there some other time. This is the whole drug. So this is the placebo, standard, and new. Under this level, we have 55. Standard drug now, just all we know there are 3 types of drug, are they? 66 patient, 49 of that dose, 64, 70, then 68. How many is there? 6 are they? For these people, 75, 93, 78, 71, 63, 76. This one is 78, 91, 97, 82, 85, and then 80. No, wait. Okay, 77. Good. Any questions? This is the question, Abby. I'm going with the question. I don't want to give you formula. We stop there. We'll continue from where we stop some other time. But let's see correction factor. Let me write it. Put correction factor, which is known as CF, is given as the ground total square all over capital N. You know, capital N is N times K, Abby. Hello. N is 18. K is what? 6. Abi? So that's the total number of observation. Everything is 6. This is 6 now. Small n. This is 6, Abi. Times 3, that will be 18. Abi? Or you count. Still 18. NK. Small n. But if you NK is equal to capital N, Abi, which is 18. If you count everything, it's 18. So I know you remember N and then K. N is observation. K is the treatment. And treatment is 3. That one has got. That's the formula for that one. Another one, TSS. That is the total sum of what? Squares. Is a summation of y square ij j to k I to k. What it means there is that the minus correction factor. See this one. This is y. This is y. This is y ij, or let me say y1. Okay, y1 1. No, there's the roll and what column here. So if I square this till the end, I'll get this. But I can just square this side, 55 square plus 66 square plus this one square plus that one square. Yeah, you following? So all the squares I got here, if I got one here, total here, if I sum all these 3 together, that's why I say 2 sum. You know, you have already summed the first one, and you are summing the 3. That's why I see summation 2 times. If you square all these and add them together, this first sum, second sum, third sum, then square all the sums. That is this one. Subtracting with this correction factor you have already got. That will give you total sum of what? Which is this place, Abi? If I square this, maybe I got 10, let's assume. I square this, I got 20. I square this, I got 15. I will add all of them together as this. Are you following? You know, I already squared them and got a value here. Sum of all that square. That's why I see 2 sums. The first sum is to get this. The second sum is to the 3. Good. Oh. Subtract from the result you got here, Abi. So what is G square? Very good. G square is the grand total. The grand what? Total. Is that okay? Grand total of all of them. Grand total. That grand total, you raise it to by what? 2. And you get your what? The result. Oh, well. That's grand total. So it would be, because you are saying that I'm hearing you. I would have all the rules that columns that I'm getting get back, which is N. Oh. You have them, Abi? My friend? Yes, sir. Let's pause here. We need to pause because it's already we can't delay. We can't take much time. I thought he came. No. What is important here is that we will continue from here. What is just understand that I gave you where I did not give you more. We'll continue from because everybody has time. He has something he's doing, and we can't continue keeping the man waiting. After all, we won't pay him his money, he didn't collect, and you also need him for the exam. Well done. Well done. You're welcome.
It's not something like why do I do it?
I mean, at this one, you're going to start. I feel that being OBJ also makes sense. If you read